Well, welcome to the third lesson. So today we're going to investigate another way of writing the equation of a line. And before we start talking about how to execute the new method, I'll just show you what this looks like and where it came from. So the new format, it's called a point slope form, right? And this is how the equation of a line looks like in this format, right? And there's a reason why we may choose to use it. But let's investigate and see where all these numbers came from. So first up, let's go through the steps here. It says, determine the slope of the graph, right? So determine the slope of the graph. We just pick 2 points on the graph. So I'll pick A, and I like to pick points at crosshairs, so it makes it easier to count. So our rise going up 1, 2, 3, 4. Our rise is 4. And our run is 1, 2. So our slope is 4 over 2, which we can say is equal to 2. In B, they're asking us to list the coordinates of point A. Well, point A is right here. That x value is at 1, and the y value is at -3. Finally, compare the information we just got to the equation of the line that is given. So y plus 3 is equal to 2x minus 1. While comparing them, this here is our slope, has the same value as our slope. Right? And then these numbers shown here are very similar to what we said for point A, but not quite. Right? This is plus 3, and an equation for y, or y, so it is -3. So this has the opposite sign. Same with here. We have -1, but our value for a point A is +1. So opposite sign. Right? Well, how do you make opposite signs? By multiplying by -1. So if we had to come up with the equation, a general format for equation of the line, it would look something like this. Y minus our y point is equal to our slope multiplying x minus our x point. Right? And this is known as the point slope form. So let's skip a page here. I'm not going to do the next investigation, and we're going to go straight to working with this equation. So we're going right to here, just above where it says equation 1. All right. So this is known as the point slope equation, and it looks like y minus y1 is equal to mx minus x1. And you may be wondering, just getting comfortable with the y-intercept form, y is equal to mx plus b, why do I need to use this equation? And honestly, y equal to mx b, the slope y-intercept form, is the one you're going to use like 99% of the time, right? However, depending on the information you've given, you may use other formats. So the point slope equation comes in handy when you know the slope and another point which isn't the y-intercept. So let's put it in terms of science. You know the rate of change and a data point. So with those two pieces of information, you can come up with the equation of the line, right? The slope y-intercept form only works when you know the y-intercept. So this one works for any other point other than, including the y-intercept, okay? So let's put this equation to work. So example 1, we're given a point on the line, 6, 5, and the slope of 3. Determine the equation in point slope form. Right, so it's going to be y minus our y value. Well, y value is 5. So we go minus 5, right, equals our slope, which is 3 times, in brackets, x minus its x value. So our x value here is 6, so minus 6, and that becomes our equation of the line. So pause the video and determine the equation of the line for B and C. Hopefully you found this relatively straightforward. It's simply plugging in the points, but you do need to be careful with the negative numbers, right? So just make sure you pay attention with the negatives, and hopefully you came up with these two answers. If not, just send me an email or set up a tutorial. We're going to work out how to do the arithmetic behind these. But I think most of you guys would be finding this relatively straightforward. Now, we know how to apply this. We know how to apply this when we have a slope and a point. Now, this slope point format is not as useful as the y-intercept, the y equal to mx format. Because from just looking at this equation, we know what the rate of a change is, and we know the y-intercept. And the y-intercept comes in handy so much because we always want to know what are the conditions at the starting point. That's the y-intercept, when the x value is equal to 0. And usually in science, we start off with our x value being time. So what's happening at the initial starting point at 0? So this format is quite handy, and we use it most often. Right? So if you're given information that helps you create the equation on the line in the point slope format, as we have given here, often we want to convert it to the slope y-intercept form. Right? So that's what this next question is investigating, right? We start off, right? And we can write out the equation if we like, or you can memorize it, right? We plug in our values. So we have y minus our y value, which is a 2, right? Is equal to our slope, which is 5, multiplied by x minus our x value here, which is negative 5. Right? Right, now we clean this up and get it to the format we're used to. So y minus 2 is equal to 5, x, 2 negatives make a positive, x plus 5, right? So this is in slope y-intercept, is not in slope y-intercept, it's in point slope form. To convert it into the slope y-intercept form, we need to multiply this out and collect our term. So it equals y equals something, right? So we need to multiply this 5 through the brackets. Maybe I'll switch to our orange here, right? So we end up with y minus 2 is equal to 5x plus 25. Next, we move the negative 2 to the other side by adding 2. So we end up with, say, I'll go plus 2 to this side, plus 2 to this side, and we end up with y is equal to 5x plus 27, right? Put a little box around it, right? So it comes in handy to know the equation in this format. So pause the video and try B and see if you can do the same thing. Now with these questions, I hope you come to the point where you think the concepts are actually pretty straightforward, it's not too difficult, and the errors that you encounter are more arithmetic errors, right? So usually what I find students say, yeah, I get it, but then they make mistakes with the arithmetic, multiplying, adding terms. So That's what I want to caution you about. Just be careful with the signs when you're multiplying and collecting terms. So when you input these values, you should end up with y is equal to negative 7x minus 17. Okay. In the next question here, we have John and Nikki both been given the same quiz. And in the quiz, they want the equation of a line in slope y-intercept form. That's the y equals mx, please. And they say you're given a line with a slope of negative 2, which means our m value is equal to negative 2, and it passes through the point 3, negative 5. Right? So we have two students working here. We have John and Nikki, right? And they said John couldn't remember the slope point formula. And he only remembered y is equal to mx plus b. So that's how he started his work. Whereas Nikki started with the slope point form, right? And it says, please complete the work and come up with the equation in y-intercept form, right? Now, the whole point behind this question is these are both equations of a line, right? At the end, you should end up with the same value. It doesn't matter what approach you take. One method may be a little bit more efficient than the other. So John's method here, he goes y equals to mx plus b. He plugged in the value of our slope. Then he doesn't know what the value of b is. So he plugs in the point that you're given. Well, we know the y value is negative 5. We know the x value is 3. Then we multiply and we solve. Right? So negative 5 is equal to negative 6 plus b. We move the 6 over to the other side. We have 1 is equal to b. Right? So now we know the slope, which is 2. We know the b value, so we can say y is equal to negative 2x plus 1. Right? And with Nikki's method, she goes and she sticks in the slope value, and she puts in the x and y values. What to do next is to simplify, collect terms, and move things around. So we have y, two negatives make a positive, y plus 5, negative 2, x minus 3. You multiply the 2 through the brackets, negative 2x plus 6. And you move the 5 over to the other side just by subtracting 5. So we have negative 2x, 6 minus 5 becomes 1. And we end up with the same equation. And that's what I want you to realize here. It doesn't really matter which method you take. Unless I specifically ask you on an assignment or a test, please use this method. Use whatever method works for you. Let's move on to the next question. Here, we're given a graph of a line and asked to determine the equation in slope y-intercept form, right? So this is exactly what you did in the last lesson, right? You're given a graph, come up with the slope y-intercept form, which is y is equal to mx plus b, right? So why, Mr. Dollywell, are you teaching this right now? Now, the reason is, in order to use the slope y-intercept form, we need to define the slope, which is easy to do off a graph, and also use the y-intercept, right? Which we just simply read off the graph. Everything in the last lesson at the y-intercept crossed at a nice, perfect crosshairs of two lines, so you can easily read the value. Here, we're going in between two values, so we're going to have to make a judgment call of what this y-intercept is, right? And as soon as we do that, we're introducing inaccuracy into our equation, right? So it's best off to use a different method which is more accurate. So we can use the slope point form, right? In order to use the slope point form, we need to know our slope and a point. And that point can be anything, any point on the line. It doesn't have to be the y-intercept. So we can pick a point that where it lines up at crosshairs, all right? So let's first find our slope. That's what we typically do. And we're gonna pick, you can pick any 2 points on the line. I'll pick this one here, and I'll pick this one here, all right? And determine our rise over run. So we're going in the downward direction, 1, 2, 3. So our rise is -3. Our run is 1, 2, 3, 4, -3 over 4. Right? For our point, we can use any point on the line. So might as well just use some of the points that we're already using. This point here is x value is -6, a y value is 0. This point here is our x value is -2, and a y value is -3. Right? Now you can use either one of those 2 points. I suggest being a little clever here and thinking one step ahead. Well, if we're using the point slope form, we're going to plug in a point, and we're going to have to multiply things out and collect our like terms in order to turn into the y equals mxb form, the slope y-intercept form. If we're doing all that arithmetic, you know what? Usually it's easier if there's a 0 in there. With 0 times anything is 0, things disappear, it makes things a little bit cleaner. So I'm going to suggest we use that point. We're going to use the point -6, 0. You could have used the other point or any other point on the line. Just the arithmetic will be a little bit easier if you use this one. So our equation of the line was y minus y1 is equal to mx minus x1, and we just plug in the information. So y minus the y value, which is 0, is equal to m, -3/4, x minus the x value. So x minus -6. So clean this up. So y minus 0, the 0 disappears, -3/4. X, 2 negatives, make a positive, so it becomes x plus 6. Right? Now we multiply the -3/4 through the brackets. Right? And we get y equals -3/4 x minus 18 over 4. Now the minus 18 over 4 we can simplify. Right? So let's rewrite this as y is equal to -3/4 x, and 18 over 4, 2 can go into both, becomes 9 over 2. Right? And the last question that we're going to do together here today is examining equations of the line and pulling out what the slope is and a point on the line. Right? So they're not all in the same format, right? So have a look at these. I'll do the first one with you guys. All right? Looking at A here, this is in slope point format. We know the slope is going to be the m value, which is in front of the brackets there. So the slope is 1 over 7. Now our point our y value is there and x value is here. So our point, remember in our equation, is these are minus y minus x. So our point is not -4 for x value. It's actually going to be 4 and -11 because of these negatives here. All right. So that's a slope, and that's a point. Look at B, C, and D. Pause the video and see if you can find the slope and a point on the line. Okay, in B is very similar to A. We come up with the slope as -5/3 and the point is 7.9. Not going to talk about that too much. C here, we're given equation of a line that sort of looks like the slope point format, except for there's nothing attached to the y, right? This is because the point that we're going through is 6, 0. The y value is 0, right? So our slope is still -3, and our point is 6, 0. Our last equation here is not given in slope point form, but in y-intercept form, right? The coefficient in front of x is our slope, and the -6 represents our y-intercept. So for our y-intercept, our x value is always equal to 0, and our y value is -6. All right, so hopefully this is slowly starting to click. Give the homework questions a try. If you have any issues, please do not hesitate to contact me.